बैक लर्नर्स। तो टुडे वी आर गोइंग टू स्टार्ट विद सीपीयू रजिस्टर्स। तो आज हम देखेंगे सीपीयू रजिस्टर होते क्या है। इन कंप्यूटर आर्किटेक्चर द रजिस्टर आर वेरी फास्ट कंप्यूटर मेमोरी which are used to execute program and operations effectively और you can say efficiently। तो जब भी हम कंप्यूटर रजिस्टर्स की बात करते हैं तो ये आपकी वेरी फास्ट, बहुत ही तेज कंप्यूटर मेमोरी होती है जो कि प्रोग्राम्स को एग्जीक्यूट करने में और ऑपरेशंस को एफिशिएंटली एग्जीक्यूट करने में हेल्प करती है। The purpose of having registers is the fast retrieval of data for processing by CPU. So if you are using a CPU register, then the purpose इसका है कि भाई ये डेटा को फास्ट रिट्रीव करता है जो कि मेमोरी के अंदर स्टोर होते हैं और रिट्रीवल प्रोसेस को बाय सीपीयू फास्ट करता है। हमारे पास डिफरेंट टाइप्स ऑफ मेमोरी रजिस्टर्स हैं, जिसमें से पहला रजिस्टर है जिसको हम बोलते हैं एक्यूमुलेटर रजिस्टर, जिसको डोनेट किया जाता है एसी से। देन वी हैव फ्लैग रजिस्टर जिसको हम डोनेट करते हैं एफआर से, सिंबॉलिक रिप्रेजेंटेशन है। एड्रेस रजिस्टर को हम डोनेट करते हैं एआर से। डेटा रजिस्टर इज रिप्रेजेंटेड बाय डीआर। प्रोग्राम काउंटर इज रिप्रेजेंटेड बाय पीसी। Instruction register is represented by IR. Stack control register is represented by SCR. Memory buffer register is represented by MBR और index register is represented by IR। तो जितने भी यहाँ पे रजिस्टर मेंशन है, हर रजिस्टर का सिंबॉलिक रिप्रेजेंटेशन है जो कि यहाँ पे मैंने अभी आपको बताया है। और आगे बढ़ते हैं और देखते हैं कि ये रजिस्टर जो है इनका क्या काम है, व्हाट इज द वर्किंग ऑफ these registers and what are the various sizes of these registers। So moving further, तो पहला हमारे पास जो रजिस्टर था उसका नाम था एक्यूमुलेटर, और एक्यूमुलेटर का जो यहाँ पे सिंबॉलिक नोटेशन है वो है AC। तो आप देख सकते हैं यहाँ पे AC इसका सिंबॉलिक नोटेशन है। द साइज ऑफ एक्यूमुलेटर इज 16 बिट, 0 से लेके 15 तक ये इसका रेंज रहता है। एंड इट इज यूज्ड फॉर storing data for ALU operations। So if you are performing an ALU operations, then the data is being stored over here in this accumulator। So then at second we have a program counter register। program counter register जो है वो आपका PC से डोनेट किया जाता है, सिंबॉलिक रिप्रेजेंटेशन जो है, और इसका साइज जो होता है वो 12 बिट्स का होता है। then the job of this register is to point to the next instruction। तो जो भी next instruction है इसको point करता है। After that we have a instruction register which is represented by IR, and the size of instruction register is 16 bits and it stores the instructions which are to be executed in a computer memory। तो इसका काम है instructions को store करना। Then we have data register which is another type of register which is denoted by DR, and the size of data register is 16 bits and the job of data register is to store the data। so जितना भी data है आपका डेटा रजिस्टर में आपका स्टोर होता है। After that we have a address register। The job of address register is to store the address of the memory। The size of this register is 12 bits and it is denoted by AR। The symbolic representation is AR। Then we have temporary register। So temporary register stores the temporary data, you can see over here, and it is represented by TR along with the size of 16 bit। तो इसका 0 से लेके 15 है which is 16 bit। So these are the different types of registers along with their symbolic representation, their name, the sizes and the functions of each and every register। So now understand the memory representation of each and every register। For example, if I am talking about program counter register, then the starting address is 0 and maximum it can take 11। So we have 12-bit register over here। So now let's talk about address register, which is known as AR in the symbolic representation। The size of address register is 12 bits and the starting address is 0 and the maximum limit is 11, which is 12 bits। So if I talk about instruction register, then the size of the instruction register is 16 bits and the starting address is 0 and maximum is 15। Then if I talk about temporary register, the size of temporary register is 16 bit, the starting address is 0 and maximum it can take 15 bit। So moving to the next, DR register, the data register is of 16 bit, starting range is 0 and maximum it can take 15 bits, and accumulator is of 0 starting bit and end is of 15 bits, so maximum is of 16 bits. So DR register and accumulator both are having 16 bit in size. Let's talk about the hierarchy of computer memory. So hierarchy of computer memory is as follows. At first we have over here, at first we have registers over here. Then the speed of registers is very high, as you can see over here, which is been represented in the diagram. And if I talk about the storage capacity is very low. And after that we have cache memory. So the cache memory speed is less than the register, and the storage capacity is more than the registers. On the other hand, if I talk about the RAM has the speed less than the cache and registers, and the storage capacity is more than the registers and the cache memory. And if I talk about the hard disk had the maximum storage capacity, and it is very slow in speed. So if or you can say this is the memory hierarchy from registers to cache to RAM to hard disk, which is represented over here, and it's talk in terms of accessibility and in terms of storage capacity. This is a block diagram of CPU, which is having the ALU control unit, memory unit, along with the cache memory, and the registers comes over here. So cache memory directly interact with the registers, and the flow of exchange of information or data takes place over here. If I talk about the size which we have discussed earlier, the size of registers are from 8 bit to 16 bit to 32-bit and 64-bit. So these are the various types of registers in size. The sizes are range from minimum 18 to 64 bit.